So here are the derivatives for the three main inverse trigonometric functions. So for arcsine x, it's 1 over square root of 1 minus x squared. And for arccosine x, it's negative 1 over the square root of 1 minus x squared. And for arctan of x, it's 1 over 1 plus x squared. And usually you're expected to memorize these theorems. And in IB, in the formula packet, they give you the theorems there. And for example, if you have sine inverse of x squared, then in order to differentiate this, first you just use the chain rule by doing 1 over square root of 1 minus x squared, as shown by this formula, and as always multiply it by the derivative of the inside times 2x. So it's just the same process as any other derivative. However, for these kind of functions, where secant, cosecant, and cotangent, you're expected to know how to differentiate these, not by memorizing a formula. And the method I'm about to show you also works for sine, cosine, and tangent if you want to remember a way to figure out what the derivative is without just memorizing a formula. So in order to solve this, we can set secant inverse secant of x equal to y. This is our function, and if we want to differentiate it, and we can also rewrite it as secant of y is equal to x, because this is a inverse function. So we just differentiate this using implicit differentiation, and we get secant y times tangent of y times dy over dx equals 1, and dy over dx is equal to 1 over secant y times tangent y. And dy over dx, what it's equal to, is going to be our solution to this. That wasn't obvious. But you can't just leave your answer in terms of y. You have to do it in terms of x. And the way that we do that is we can draw a triangle, and a right triangle with an angle y degrees, or whatever, because we have secant of y, so y has to be an angle. And if secant y is equal to x, that means that since secant is hypotenuse over adjacent, then that means we can write our hypotenuse as x and our adjacent side as 1, because secant of y is equal to x over 1. We're just writing the side so it matches our equation. And we can use the Pythagorean theorem to figure out this side, which is, well, let me show you. 1 squared plus, let's label this m squared equals x squared. So m squared equals x squared minus 1, and m is equal to square root of x squared minus 1. So, and we can rewrite our side as that. Square root of x squared minus 1. And now we're able to figure out what secant of y and tangent of y are. So we already know from our equation here that secant of y is x. So let's rewrite that. 1 over x times tangent of y, that's the opposite side over the adjacent side, which is just square root of x squared minus 1. And that's our final answer. However, if you notice that whenever you plug in a negative number for x, the slope is going to be negative, and that can't be right. So we set absolute value into this x, because whenever you put something into inverse secant of x, it should not be negative. So let's do this example problem that says find dy over dx for y equals x times inverse sine of x. Now you should just treat this problem like any other derivative problem, because you know what the derivative of inverse sine of x is, or you have it down somewhere as a formula. So we can use the product rule for this one. So dy over dx is equal to 1 times inverse sine of x plus the derivative of inverse sine of x, which is 1 over the square root of 1 minus x squared times x. This is just simple product rule, so it's not anything different at all. And this simplifies to inverse sine of x plus x over the square root of 1 minus x squared. And that's our final answer. Now, let's get into some practice problems. If you think you know how to do this one, then pause the video and try it. This problem says, find dy over dx for y equals inverse tan of 2x. And now this one's also not different as well. You can just use the chain rule, considering you should already know what the derivative of inverse tan is. So dy over dx is equal to, let's take the derivative of the outside first, 1 over 1 plus x squared, but it has to be 2x squared because we have to leave the inside unchanged. So 2x squared, and we can just rewrite that as 4x squared. And multiply this by the derivative of the inside, which is 2. And this is simply just 2 over 1 plus 4x squared. And that's our final answer. Now let's do another practice problem. If you think you know how to do this one, pause the video and try it. This one says, find dy over dx for y equals inverse cosine of x over 5. And again, you should treat this problem like any other derivative problem. And for this one, we can use the chain rule. So dy over dx is equal to the derivative of the outside, and you should know this formula, negative 1 over the square root of 1 minus x squared, but we have to keep x unchanged, x over 5 squared, multiply it by the derivative of the inside, which is 1 over 5. Now let's simplify this to negative 1 over 5 times 1 minus x squared over 25, which is 5 squared. And we should try to get rid of this compound fraction, and luckily in this case it's pretty easy. If you put the 5 back into the square root by just setting it as the square root of 25, then we get negative 1 over the square root of 25 minus x squared. And that's our final answer. So everything that I explained in this video and all the problems that I went through should teach you everything that you need to know about inverse trigonometric derivatives. If you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.